Welcome to our channel, where we bring you the most interesting and informative content from around the world. Deep beneath our feet lies a mystery. It's a place we can never visit, hidden by layers of rock and metal. This is Earth's core, a sphere of iron and nickel larger than the planet Mars. The core is divided into two parts. The outer core is liquid metal, constantly moving and churning. The inner core is a solid ball of iron, under immense pressure and heat. Though hidden from view, the core plays a vital role in our lives. It's the engine that drives Earth's magnetic field, our shield against harmful radiation from space. Earth's core isn't static. The inner core spins, and the liquid outer core flows around it. This movement is driven by heat escaping from the core, creating swirling currents of molten iron. Imagine a pot of boiling water. Heat from the stove causes the water to move, creating currents that rise and fall. The core's movement is similar, though on a much grander scale. This constant motion within the core is what generates Earth's magnetic field. Like a giant dynamo, the flowing metal creates electrical currents, which in turn produce a magnetic field that extends far out into space. Earth's magnetic field is our invisible protector. It acts like a shield, deflecting most of the charged particles streaming from the sun, known as the solar wind. Without the magnetic field, these particles would bombard our atmosphere, stripping it away over time. Mars, which lost its global magnetic field billions of years ago, suffered this fate, leaving it with a thin atmosphere and a dry, desolate surface. The magnetic field also protects life on Earth from harmful radiation. Cosmic rays, high-energy particles from deep space, are deflected by the magnetic field, preventing them from reaching the surface and harming living organisms. What would happen if Earth's core suddenly stopped rotating? It's a scenario explored in disaster movies, but what does science say? While it's unlikely to happen overnight, a gradual slowing of the core's rotation is possible. In fact, some scientists believe the core may be in the process of slowing down right now. If the core's rotation were to stop completely, the first and most immediate effect would be the weakening of Earth's magnetic field. Without the dynamo effect of the flowing outer core, the magnetic field would gradually decay. Section 5: A World Without a Compass. A weakening. Magnetic field would have a cascade of effects, some more immediate than others. The Earth's magnetic field is a crucial component of our planet's ability to sustain life as we know it. Compasses, which rely on Earth's magnetic field for navigation, would become unreliable, pointing in random directions. This seemingly simple tool has been a cornerstone of human exploration and travel for centuries. This might seem like a minor inconvenience, but it could have serious implications for navigation, especially in remote areas where modern technology might fail or be unavailable. Particularly for ships at sea and aircraft in the air. These vessels often traverse vast, featureless expanses where traditional landmarks are non-existent. Modern navigation systems rely on GPS, which is a network of satellites orbiting the Earth. However, these systems are not infallible. But a backup system based on traditional compass navigation is always crucial. In the event of a GPS failure, having a reliable compass can mean the difference between safety and disaster. Animals that use Earth's magnetic field for navigation, such as migratory birds and sea turtles, would also be affected. These creatures have evolved over millennia to rely on the magnetic field for their long journeys. Their ability to navigate across vast distances could be disrupted, potentially impacting their survival. The loss of this natural navigation system could lead to disorientation, failed migrations, and even population declines. Humans, too, are more dependent on the Earth's magnetic field than we might realize. Beyond navigation, the magnetic field protects us from harmful solar radiation. Without it, the planet would be bombarded with high levels of radiation, which could have devastating effects on our health and the environment. Historically, the Earth's magnetic field has undergone changes, including reversals where the magnetic north and south poles switch places. These events, while rare, have had significant impacts on the planet. As we look to the future, understanding and preparing for the implications of a weakening magnetic field is crucial. It is not just a scientific curiosity but a matter of global importance. Scientists around the world are studying these changes, using advanced technology to monitor the magnetic field and predict its future behavior. Global efforts are underway to mitigate the potential effects, ensuring that both human and animal life can adapt to these changes. While the challenges are significant, there is hope that through innovation and collaboration, we can navigate a world without a compass. Section 6. Cosmic Rays Run Wild. As the magnetic field weakens, Earth becomes more vulnerable to cosmic rays. These high-energy particles can penetrate deep into the atmosphere, increasing radiation levels on the surface. While the increase in radiation wouldn't be immediately life-threatening, it could have long-term consequences for human health. Exposure to elevated levels of radiation can increase the risk of cancer and other health problems. The impact on other life forms is less clear, but increased radiation could potentially lead to mutations and genetic damage, with unpredictable consequences for ecosystems. Section 7. The Atmosphere in Peril. The weakening magnetic field could also have implications for our atmosphere. This magnetic field, generated by the movement of molten iron in Earth's outer core, acts as a shield, protecting our planet from the solar wind. Without this shield, the solar wind, which is a stream of charged particles emitted by the sun, would have a more direct impact on our atmosphere. With less protection from the solar wind, the atmosphere would be bombarded by charged particles, gradually stripping away its outer layers. This stripping process is not immediate but occurs over an extended period. The solar wind can erode the atmosphere by knocking atmospheric particles into space, a phenomenon observed on planets like Mars, which has a very thin atmosphere due to its weak magnetic field. This process would be slow, happening over millions of years, but it could eventually lead to a thinner, less protective atmosphere. The gradual loss of atmospheric particles would mean that the atmosphere becomes less dense, reducing its ability to shield the surface from various space weather phenomena. A thinner atmosphere would offer less protection from harmful ultraviolet radiation from the sun, further endangering life on Earth. Ultraviolet radiation can cause severe damage to living organisms, including increased rates of skin cancer in humans and harm to the DNA of various life forms. The ozone layer, which absorbs and scatters the majority of the sun's harmful UV radiation, would be less effective in a thinner atmosphere. The loss of atmospheric gases could also impact Earth's climate, potentially leading to changes in temperature and weather patterns. A thinner atmosphere would mean less greenhouse gases, such as carbon dioxide and methane, which are crucial for maintaining Earth's temperature. This could result in a cooler planet, altering ecosystems and affecting agriculture and water resources. The exact nature of these changes is difficult to predict, but they could have significant consequences for life on Earth. Scientists are continuously studying these potential impacts to better understand how our planet might change and to develop strategies to mitigate these effects. The future of Earth's atmosphere is uncertain, but understanding these processes is crucial for preparing for and potentially preventing adverse outcomes. Section 8. Life on the Edge. While a sudden and complete shutdown of Earth's core is unlikely, even a gradual weakening of the magnetic field could have profound implications for life on our planet. The increased radiation exposure, atmospheric loss, and potential climate changes would create a more hostile environment for many life forms. Some species might adapt, while others could face extinction. The impact on human civilization is difficult to predict, but it would undoubtedly be significant. We rely on technology that is vulnerable to radiation, and our society is built on a stable climate. A changing Earth would require us to adapt and innovate to survive. Section 9. A Silent Warning. The hypothetical scenario of Earth's core stopping is a stark reminder of the delicate balance that supports life on our planet. Imagine a world where the very heart of our planet ceases to function. The core, a molten iron dynamo, is crucial for generating the magnetic field that shields us from harmful solar radiation. The seemingly solid ground beneath our feet is anything but static. Beneath the surface, a dynamic and ever-changing environment exists, driven by the movement of tectonic plates and the flow of molten rock. This geological activity is responsible for earthquakes, volcanic eruptions, and the creation of mountain ranges. Deep within Earth, forces are at work that shape our world in ways we are only beginning to understand. Magma, the molten rock beneath the crust, moves and shifts, creating new landforms and altering existing ones. These movements are a testament to the planet's constant state of flux. The core's rotation, the magnetic field it generates, and the protection it provides are all interconnected parts of a complex system. This magnetic field not only shields us from solar winds but also plays a crucial role in navigation for both humans and animals. Without it, life as we know it would be drastically different. By studying the core, we gain a deeper appreciation for the preciousness of our planet and the importance of protecting it. Researchers use advanced technology to peer into the depths of the Earth, uncovering secrets that help us understand the past and predict future changes. Understanding the forces that shape Earth is essential for our continued survival. As we learn more about these powerful processes, we can better prepare for natural disasters and mitigate their impacts. This knowledge is vital for developing strategies to protect our environment and ensure a sustainable future for generations to come. Section 10: Mysteries of the Deep. Despite advances in technology, Earth's core remains largely a mystery. We cannot drill deep enough to sample it directly, so we rely on indirect methods to study it. Seismology, the study of earthquakes, provides valuable clues. By analyzing the way seismic waves travel through Earth, scientists can infer the composition and structure of the core. Other methods, such as laboratory experiments that recreate the extreme pressures and temperatures found in the core, also contribute to our understanding. Yet, many questions remain unanswered, driving further research and exploration. Section 11: Our planet's future. The fate of Earth's core is inextricably linked to the fate of our planet. As we continue to learn more about the core, we gain a deeper understanding of the forces that shape Earth and the challenges we face. Climate change, resource depletion, and other environmental problems pose significant threats to the delicate balance of our planet. By understanding the interconnectedness of Earth's systems, we can make more informed decisions about how to protect our home. The study of Earth's core is not merely an academic pursuit but a vital endeavor that can help us safeguard the future of life on Earth. Thanks for watching. Don't forget to subscribe, like, comment and share.